Good afternoon, guys. I hope you all are doing all right. I'm going to go ahead and go over the solutions to this review problems that we started to do in class. So I'll kind of just give you some notes and walk through them, and hopefully you guys will be able to follow along. This will help you prepare for the test tomorrow. So the first thing I want to go over is problem one. What's the difference between standard slope intercept and slope and a point slope? So remember, slope intercept form is looks like y equals mx plus b. Okay? Standard form looks like this: ax plus by equals c. So that's when you have an x and a y and then some coefficient on the other side of the equal. And the last form we're going to look at is the point slope. And that's basically when you're given like the slope and a point. And it's going to look like this: y minus y1, where that's part of the point given, equals m, which is the slope, and then x minus x1, which is usually the x1 and the y1 are given. So let's take a look. If you wanted to identify, well, this looks like y equals mx plus b. This would be the slope, and that would be your y-intercept. So A is going to be slope-intercept form. B looks like y minus y1 equals slope x minus x1. So what's given is our x1 and our y1, which is this and this. Okay, that's just extra info. You don't really need that, but it's just so you can recognize why this is the point slope form. This one really easy, right? It looks like ax plus by equals some coefficient. That's a c. Equals some coefficient. So that's going to be the standard form. Okay, I know I didn't go over this with you guys, so it's probably from way back like the first or second week of school, and you guys probably just watched the video on this. So I'm gonna go over it a little bit, but you won't really need this for the exam, but you will need to know how to go back and forth between these different forms. How about this? Looks like ax plus by equals some coefficient, right? When you only have an x and y, it's going to be standard form. All right, now these, you can graph them by hand, but you're going to be able to have access to a graphing calculator. So for 2, A, B, C, and D, I wouldn't really worry about trying to graph these. If you wanted a bit of a review, remember in this form, the slope is 2, the y-intercept is -5. So we're going to go here to -5. It's always on the y-axis. And then the slope also equals the rise over the run. So we're going to go from this point, we're going to go up 2 and over 1. Up 2 and to the right. To the right 1. Then you go up 2 and to the right 1. Up 2 and to the right 1. Up 2 and to the right 1. So forth and so forth. Now you can graph it. Okay. This one is useful because it's already in point slope form. Remember, point slope form looked like this, where this is the slope. So our slope is -1/2, and our point given is going to be, this is x1, that's y1, so our point is going to be 3 comma -1. So we know that no matter what, we're going to have a point at 3, -1. And then from there, we'll have to figure out what the line looks like by plotting points. We start here and we get that -1/2 slope, which is what I'm getting from right here. So we go, it's negative, so we go down 1 to the right 2, down 1 and to the right 2. If we're going the opposite direction, we're going to go up 1 and to the left 2. Up 1 and to the left 2. Now these, you can't really graph them straight away from the standard form. What they want you to know from this is how to convert this standard form to the point slope form or the slope intercept form. I think the easiest is slope intercept. That'll allow us to graph straight away. So what I'm going to do is try to isolate y by itself by subtracting 3x from both sides. Those will cancel, and I'll be left with 4y equals negative 3x plus 6. Divide by 4 to get rid of the 4, and then y is going to equal negative 3/4 x plus 6 over 4, which is the same as saying 3 over 2. Remember, now in this form, we have the y-intercept and the slope. Our y-intercept is 3 over 2, which is the same as saying 3 halves, which is like 1.5. So we're going to go to 1.5. And then we're going to have a negative slope, so we know it's going to be going this direction. We just have to figure out where the points are. And it's negative 3 over 4, so we're going to go down 3. 1, 2, 3. And then to the right 4. 1, 2, 3, 4. Down 3. 1, 2, 3. And to the right 4. 1, 2, 3, 4. So now you can see when it's in standard form, we are going to need to be able to convert that to slope intercept, and then we can easily graph it by hand. I don't know if there's any problems like this on the test tomorrow, but if you need to graph this, you can always just graph this in decimals, and it'll give you what the line looks like. Let's go ahead and show how to do this one by hand. Remember, we want to isolate y by itself, so let's add 5x to both sides. Those will cancel. We left with negative 2y equals 5x plus 15. Then we divide everything by negative 2. Those will cancel. And we're going to be left with negative 5 halves x plus 15 over 2. Okay. If you were to graph it by hand, you would have to find 15 over 2, which is the same as saying 7.5, 7.5. So you got to go all the way over here. And you got to find 7.5. The y-intercept is going to be 7.5, which is kind of up here somewhere. Then you got to go down 5 and up 2. So it's going to be like 6.5 is 1, 5 and 2, 3, 4, 5, and then over 2. Down 5, 1, 2, 3, 4, 5, and over 2. And that's going to look something like that. But like I said, if you need to graph these two, you can just graph them in decimals or in the TI Inspire. Okay. Now let's take a look at number 3. The one thing that we need to remember about... No, I don't want to do that. The one thing we need to remember about parallel and... oops, I can't erase that from before. Parallel lines have the same slope, and perpendicular lines have the negative reciprocal slope. Okay, so let me see if I can't erase these because they were in the file. Let me see if I can work it out over here. The first thing we need to do is, in order to find an equation to the line that's parallel, we need to we know that it's going to have the same slope. So we need to convert to slope intercept form. And that means I isolate y. So I've got to get everything to the other side of this equal sign. divide by -2. Get y equals 3/2 x plus 17/2. Okay. So check it out. That's our equation. That's the equation of this line with the slope of 3/2 and a y-intercept of 17/2. Okay, so I think so far you guys probably should kind of understand that, right? If I know the line is going to be parallel, it has to have the same slope. So my new line has to have the same slope of 3/2, but we don't know what b is going to be. We don't know what our y-intercept is going to be. But we are given a point, so we know that this is x and this is y. We can substitute that into the new equation, and that's going to be 2 equals 3/2 times 1 plus b. We solve for b, and that's going to equal 2 minus 3/2, which is going to equal 2 is 4/2. 2 is the same as saying 4/2. Minus 3/2 is going to be 1/2, which is the same as 1/2. So now we know our new slope equals 1/2. We got to just substitute that back into here. So our new equation becomes y equals 3/2 x plus 1/2. Okay? We don't even have to graph or do anything else. All we needed to do was convert this to slope-intercept, use the same slope because it's parallel, and then find our b value. Now let's do the same for number 4. The only thing we need to remember is that the slope's a little bit different. It's not the same slope, okay? So let's see. Ignore all of this stuff. X minus 4y equals 7. I want to get y by itself. So I can subtract x. Those cancel. I've got negative 4y equals negative x plus 7. Divide by negative 4. Then I've got y equals 1/4 x. So all I did was simplify this. And then I've still got this. So that's minus 7/4. Okay. In perpendicular lines, if our slope of the original line is 1/4, then the slope of the perpendicular line is the negative reciprocal, which means we flip the fraction and we switch the sign. So now we know that the new equation is going to be y equals negative 4x plus some b that we don't know what it is yet. Now, we are given the point right here. So what we can do is say negative 3 equals negative 4 times negative 4 plus b. Solve for b, which is negative 3. Okay, let's do it this way, step by step. Minus 3 equals 16 plus b. Subtract 16 from both sides. And then we have b is equal to negative 19. So our new equation, I'm sorry for the mess, guys. It's going to be y equals negative 4x minus 19. That line is going to be perpendicular to this, and it's going to pass through those 2 points. Sorry, guys. It was a little messy, but I hope the explanation helped. Okay. We did talk about symmetry a little bit, and I want to remind you of a couple of things. It's in your notes somewhere, but you have to go looking for it. So let's do this. If something is symmetrical, if it's symmetrical about the y-axis, it's even. If it's symmetrical about the origin, it's odd. And if it's symmetrical about the x, then it's neither. Let me try a different color. Okay, so symmetrical about the y-axis means if you draw an imaginary line down the y, does the left side look like the right side? And in example A, it does. So that's clearly symmetrical about the y-axis, so it's an even function. I'm going to close this. What? Let me close this. Okay. This one is symmetrical about the origin. So see, like, if we took this and kind of rotated it this way, eventually we would get this. This one's symmetric about the origin, so it's an odd. Okay. This one is neither symmetric about the y or the origin, but it is symmetric about the x. So if we draw a dotted line here along the x-axis, we see that the top looks like the bottom, so it's going to be neither. Misspelled that, but it's okay. Okay. We looked at composite functions. That's a function inside of a function. All we do is put g inside of f. So we take the function f, we write 3. Instead of x, we draw parentheses. And instead of x, we're going to put everything that is in g of x. So we write 5x plus 4. We distribute, and we get 15x plus 12. So this times this, then this times this, minus 7. We simplify. Negative 12 plus 7 is, I'm sorry, 12 minus 7. What did y'all get? 5. And that's what the answer is. Okay, that one's really simple. This one's even easier. The table to the right represents a function. Remember, the inverse of a function is just when we switch the x and y. Literally just swap x and y. So all of these, we're just going to switch them. That becomes 4, negative 4, 3, negative 2, 2, comma 0, 1, comma 2, and then this one becomes 0, 4. Okay, literally just switching the x and y. Okay, this one's graphing functions. Again, we're going to take this. It's in y-intercept form, but you could also graph it on Desmos or the TI Inspire. The intercept is negative 1, and the slope is negative 2, so I'm going to go down 2 to the right 1, down 2 to the right 1, down 2 to the right 1, so forth and so forth. So that is this function. The function x is literally just a line if y equals x. For every y there's an x, so that looks like this one is a diagonal line that looks like this. And then 2x minus 3, that's going to be negative 3 is the y-intercept, so we go to negative 3. And then the slope is 2 over 1, so we're going to go up 2 and over 1, up 2 and over 1, up 2 and over 1. Okay. So these are kind of what the lines look like, but remember, we need to start restricting the domain. So for this one, we have to remember that x is less than negative 2. So we're only going to include this part of the graph. Okay, we're not going to include anything else. So we're going to erase the rest. And it's a less than, so we use an open circle. For the blue line, for this one right here, we're restricting the domain to between negative 2 and positive 2. So x must be greater than or equal to 2. So we're going to go to negative 2 and go down. It's including that point, so we're going to draw a closed dot. And then on the right side, it's got to be less than 2. So we're going to go here, but that one's going to be an open dot. Okay. And then for the last one, x has to be greater than or equal to 2. So we're only going to look at these points and above. So we say the piecewise, it's going to look like this. That's what the graph looks like. Now the evaluate part is really simply just putting this number inside of the equation, but we have to figure out which one it is. Okay. So -4, we have to look through all of these and say, where is -4? Is it greater than 2? No. Is it between -2 and 2? No. Is it less than -2? Yes. So we're going to evaluate this guy with this number. That's 8 minus 1 is 7. Same thing with this one. F evaluated at 5. We're going to look, where's 5? Is it less than -2? No. Is it between these two? No, it's right here. 5 is greater than 2, so we have to use this equation. So f at 5 is going to be 7. Okay, and that's how we do those. Now these two, I'm just going to give you guys the formula. There's two formulas that we need to remember. The distance formula, d equals x squared, x2 minus x1 squared plus y2 minus y1 squared. And all you really need to do is take this x1 and y1, x2 and y2, and plug it into the equation. The second equation for the midpoint equals x midpoint, y midpoint. It looks like this: x1 plus x2 divided by 2, comma y2 plus y1 divided by 2. And again, all we're going to do is take this x1, this y1, and this x2, and this y2, and substitute them in the formula. Okay. Transformations are a little bit tricky. What I would do here is, for number 10, describe the transformation of the parent function from its parent function. What's the parent function? What I want to do is I want to show you guys this screenshot. I'm going to do a screenshot here and add it to these notes. Let's see if it works. Okay. So this is the general format for transformations where, oh no, how do I do that? Let's undo that. I want to bring it back. So if you have the format like let's say of an absolute value, where it's just y equals x. So when you have the parent function y equals absolute value of x, if you add some number out here, if you add a number inside, or if you add a number outside, it's going to do all of these things. Okay. So you can use that formula to try to answer number 11. That's the parent. The transformation is going to be like if you add a number to the front, if you add a number inside the absolute value, or if you add a number out here. Okay, these are the things that it's going to do to the graph. The quadratics, what I would do is I would graph these in the graphing calculator. I would literally just type this into the graph with the calculator. And then remember, if it crosses the x at wherever it crosses the x are the solutions. So you might have two solutions, or you might have a situation like this where it's only one solution. You could even have something like this that's one solution. So all you need to do is graph these into the calculator, see where they cross the x-axis, and those coordinate points are your solutions. And I would do the same for these two. I would just graph them and try to find the solution. Okay. I will be available tomorrow in the morning between 8 and 8:30. So if you guys do want to come in and ask a few questions, and maybe especially about the transformation ones or graphing these in the calculator, please come by and let me know, and I'll try to help you guys tomorrow, okay?